Hello, we are working on section 4.1, and that is all about the chain rule. So today we're going to look at composite functions and how you take their derivatives when you have a more complicated function. And this quick review will go through some items from pre-calc, get them fresh in your memory. And the first thing I notice is it says in exercises 1 through 5, let f of x equal, g of x equal, and h of x equal. Write a simplified expression for the composite function. Well, let's do a couple of them, and then we will move on. So I'm just going to highlight, there's my f of x function, my g of x function, and the h of x function. And let me just, whoops, that's not quite what I wanted to do. I want to try and lock this down. Why don't you work on problem 1, and then let's compare what we get for answers as well. All right, I am ready to go. We are going to look at number 1. G goes into F. So G will go into f of x. So everything that g of x represents goes into the x value in f of x. So I will end up with this equaling to the sine of x squared plus 1. When I look at number 2, I see 1, 2, 3 levels. We always start from the inside and work our way outside. So h is going to go into g. So we're going to have h 7x replacing x, looks like it's going to get squared. So I'm going to do an intermediate step and have f of 7x gets squared plus 1. That's taken h, putting it into g. That's going to look like f of 49x squared plus 1. And now that is going to leap into sine of x. X gets replaced with 49x squared plus 1. Number 3, that is another way to show composite functions, and we know we could write it as g of h of x. So h is going into g, and we kind of did that one last time. So 7x is going to get squared. I'm going to have 49x squared plus 1. 4 reverses it, and we will get a different function most likely from this reversed composite. So g goes into h. So this h squared plus 1 now goes in place of the x. So I'll have 7 times x squared plus 1. It did tell us to simplify the expression, so 7x squared plus 7. Woo, 5 looks tricky. I'm going to erase and try to work on 5. So I think what I need to build is what is the inner part of f, and it's going to be f with g on top, x squared plus 1, and h underneath. Can those x's cancel or reduce? No, not a chance. All right, now what is f? F is sine of stuff. And the stuff is right here, isn't it? X squared plus 1 over 7x. There's our answer. Not bad. I'm sure you guys were well prepared for those. The 6 through 10 get a little bit more difficult. I'm going to just ignore that timer. I don't know if I can get it to move over. No, not so much. So we're just going to ignore. Yeah, not so cool. 6, 7 through 7, 8, 9, 10, we have to build back to the function notation. So I see I've got a square root of cosine x plus 2. I've got a cosine x, don't I? And square root, oh, there's the square root. So really it looks to me like I have a g of x with the cosine inserted for x. So I'm going to say it's g of f of x. So that f of x goes into g of x, and that would create the cosine x plus 2 inside the radical. Number 7, cosine gets squared, and it has 3 times that. So we need that square root on the outer. That sounds like g of x. I see the plus 2, so that's good. Let's say this is going to be g of 3 f of x squared. But just the f of x needs to be squared, doesn't it? Plus 2. Oops, the plus 2 comes from our g of x already, doesn't it? That was a little bit trickier, and I'm not confident that I did it right, so I'm going to backtrack and see what happens when I plug this in. So I go to g, and I'm going to take 3 times cosine squared of x, because it told me to square the f of x, and 3 times that, and that's going to replace x. Does that give us what we're looking for? Yeah, it does. So that looks good. You can play around with the rest of them. I'm going to move on to the chain rule. So chain rule was a big deal when we encountered it in our AB last year. If f is differentiable at a point and u is equal to g of x and g is differentiable at x, then the composite function f of g of x is also equal to that notation, f with the parentheses, g of x, is differentiable at x. And we can say that the derivative of a composite function is equal to the outer function's derivative with the inside left alone, evaluated at the inner function g of x, and then multiplied by g prime of x. So we have to take the derivative of the inside separately. You remember this. All right, so first one, it's giving us a velocity and asking us to take the derivative. How many layers do you see to this function? I see an inner function of 5t minus 3 and an outer function of sine of stuff. So I'm going to start with my inner function, take the derivative of the inner function, I'm going to take derivative of the outer function and then the inner function. Derivative of sine becomes cosine. Leave that g of x alone, the inner function. Chain off, so we should get a multiplying, and multiply by the derivative of 5t minus 3, which is simply 5. And then let's organize it in a nice mathematical statement. So 5 times cosine 5t minus 3. The next example says find the derivative. We got cosine of 3x to the fourth minus 2. Once again, I see 2 levels to this one, and you give it a try, but I'm going to say y prime. I could add y is equal to that just to make sense. I get y prime. What's your first step? Well, this is the outer function, so it's going to be negative sine of g of x. G of x is this, so 3x to the fourth minus 2. No derivative on that yet. Chain off, and we have 12x cubed. I don't like the way that's written, so I'm going to organize it. Negative 12x cubed sine of 3x to the fourth minus 2. All right, the last one, how many levels do you see on that? I'm seeing 3. So let's plan it out. We know that this could also be written, instead of using the radical, we could write it as a power of 1/3, and that is the outermost function. So my outer is something to the 1/3. The next level of function is sine, and then the inside piece is x squared. So we would have y prime equals 1/3. We're using the power rule. Subtract 1 from 1/3, and we'd have negative 2/3. Leave all of the inside piece alone. So we'd have sine x squared. So that would be like if I had 3 levels, f of g of h of x, I would have f prime g of h times g prime of x of h of x times, finally, the very inner piece, h prime. So I'm going to have 3 chain offs. I did my first one. Now I'm going to chain off and take the derivative of sine. And the derivative of sine we know is cosine. Leave the inside alone. We're on that piece. And then finally one more chaining, and that's to take the derivative of the very inner piece, which is x squared, so we'd have the derivative being 2x. Organizing this into a nice, concise, simplified answer. 2 is a numerator, 2x. This is numerator cosine of x squared. I saw that negative exponent, so that tells me it belongs on the bottom. And this needs to be raised to the 2/3 power, so I'm going to use an extra set of brackets to make it very clear that it's the sine of x squared completely getting raised to the 2/3. And then this 3 is a denominator, so it looks like that. All right. That's just our answers from the early stuff. And you will have a, ignore that. It probably will be a WebAssign or a Delta Math. I'll let you know in Schoology. Thank you.